In order to find the impedance, we first have to find the reactance of the inductor and the reactance of the capacitor. So let's start with the reactance of the inductor, which is given by omega L. So this is 10,000 radians per second times 60 times 10 to the third henries, which gives us 600 ohms. Remember, a reactance is similar to the resistance value of the corresponding circuit element. And the capacitive reactance is given by 1 over omega C. So this is 1 over 10,000 radians per second times C, which is 0.50 times 10 to the negative 6 farads. And that gives us a reactance of 200 ohms. And now the impedance, Z, is given by the square root of R squared plus the quantity XL minus XC quantity squared. So the impedance in this case equals the resistance, which is 300 ohms quantity squared plus 600 ohms minus 200 ohms quantity squared, and that gives us an impedance of 500 ohms. We're asked to find the current amplitude, and the current amplitude I by Ohm's law is given by V over Z. So this is 50 volts over 500 ohms, which is 0.10 amps. And the angle, or the phase angle, is given by tangent inverse of XL minus XC over R. This should look familiar from chapter 1, the components of vectors. So this is tangent inverse of 600 ohms minus 200 ohms over 300 ohms, which gives us an angle of about 53 degrees. And if we wanted to find the voltages now across each circuit element, V sub R would be IR, which is 0.10 amp times 300 ohms, or 30 volts. V sub L equals I times X sub L, which is 0.10 amp times 600 ohms, or 60 volts. And V sub C equals I times X sub C, which is 0.10 amp times 200 ohms,